Thanks, everyone. A very good morning. Thank you, everyone, to be here listening to my talk. Okay, so basically today I'll be talking about like interoperability and how TEs and maybe AI agents can actually be a helpful component of achieving good interoperability for the entire Ethereum ecosystem. So just a little bit about like myself and Automata. My name is ZhengLeong. I'm the co-founder of Automata Network. And you might be asking like, what is Automata Network? What do we do, right? So basically we are a machine attestation layer. And your next question would be like, what is a machine attestation layer? So you can think of it as we establish trust with the machine that we are interacting with. Like, I'm sure most of you would have heard of like World Network, right? WorldCoin, where they establish that you are a human, unique individual human. In the world of like Web3 and in the world of decentralized finance, decentralized systems, the entity that we are interacting with really is not a human being. Well, the human being is the kind of like intent behind the transaction, but the actual interaction actually forms between machines. And what we want to do really is to establish that, hey, the machine that I'm interacting with is indeed a real machine. It's not some emulator running in some server farm somewhere across the world in some dingy data center, right? For example, it is indeed the server that is running say it is my phone that is actually running the client of a particular DEX that issues out a particular user transaction. So this is what we do. We have this kind of like rollup where you can establish trust and authenticity with the machine that we are interacting with. And we can extend this trust into decentralized systems, into AI systems, and this acts as a kind of like anchor where we can do interesting things like maybe improve Sybil resistance for our protocols, increase robustness of our systems. We can even kind of like make it more secure for us. For example, I can have a wallet that is associated with a particular device, my phone, for example, and any transactions that don't come from my phone, we would actually just like block it. Those are just some applications on what we can do with it. So currently, we actually have multiple collaborations. For example, we have this multi-prover AVS with Linear and Scroll, where we kind of like act as a second factor prover for their networks. So instead of relying solely on ZK proofs as the kind of like sole validating system, we can actually have an alternate kind of like check, just like how Ethereums have multiple clients to make it more robust. We do so for prover systems. So Scroll, for example, have a ZK proof system. We implement the similar state transition functions in the TEE, and that kind of like acts as a cross kind of like check and balance. And of course, other than all of this, right, in order for people to make use of this machine trust, we also open source a lot of like different libraries, SDKs for developers to build on all these sort of trusted machines, trusted execution environments. So I think enough of that introduction. Let's go into the topic proper, like what is interoperability and what is the state of interoperability today? So there is that kind of like thinking that, hey, you know, for Ethereum, we can have rollups, we can have sidechains. We can have this big ecosystem where different sovereign domains, you can think of a chain as a single kind of like domain, which is self-sovereign. Each chain can actually have certain specialization in which they do certain things really well. For example, for the Automata Network, we are an attestation layer. So that's kind of like our meat in the game, our beef. we can kind of like have really efficient ways for people to verify the machine attestation. There can be some chains that are more focused on, say, providing low latency transactions for gaming, and then there are certain chains that focuses on privacy. So each chain can have their own kind of like niche specialization, and all of us work together in this like big happy ecosystem. Great, right? Well, there is an issue here, which is like the kind of like friction that occurs when we want to move our asset or to communicate across all of these chains or all of these domains. The user experience really in kind of like using all this cross-domain application, it's not so desirable. I remember like last year during Bangkok, there was this interoperability summit. I'm not sure if anyone of you actually went there. Vitalik actually locked everyone in the room and said that, hey, maybe we should kind of like decide on how we can actually standardize like, for example, accounts across all the different chains such that we can make interoperability easier, better. So this kinds of like bring us to what interoperability really is. Fundamentally, interoperability is the ability for us to communicate across the different domains. The ability to, for example, transfer assets and messages, like data in general. And what do we want to achieve here is to kind of like minimize trust assumption and complexity for users. The best thing is for the user don't even know that they are actually crossing what's that called, domains or crossing chains. To the user, it's just one big blockchain. So like what are some of the challenges and how can we, what are some of the challenges on achieving that? What are some of the desired properties that we want to see for all this sort of interoperability between chains? Number one, of course, is like your security and trust assumption, right? Like in most cases, because each of the chain is its individual sovereign domain, messages like each of the chain actually don't have a view on any data outside of its domain. And the way how they kind of like obtain all this data is through kind of like oracles or light clients or some external source of information. This typically involves a bridge or an oracle. So the existence of all these bridges and oracles really introduces new trust points and kind of like trust assumptions into the system. And different kinds of, what's that called, bridging or message passing oracles have different assumptions. So for example, for optimistic bridges, there is a 7-day withdrawal, 7-day period for the message to be finalized. Validity bridges have less confirmation window, so on and so forth. Different domains or like different chains have different consensus models or modes too. Like some uses a centralized sequencer, some uses multiple sequencers, some, for example, base Rollup uses the base Ethereum validators to perform the sequencing and the ordering of all these transactions. There are also, what's that called, proposals to have like shared sequencer where a whole bunch of chains would come together and say that, hey, you know, like all of us, we would give up a little bit of our sovereignty to a shared sequencer such that transaction can be ordered across all of these chains. Finality and latency is kind of like similar to what I've kind of described earlier on certain trust assumptions and security assumptions of the different bridges and oracles. And of course, we are back to that fundamental issue of interoperability, user experience, like this multi-step user experience of identifying what is my account on chain A, what is my account on chain B, what is the asset, what are the ways on how I can bridge an asset or pass a message or call a function. All this introduces friction into the user experience, and this would cause us to actually lose users. So what are some of the properties that we would want to see in this, like in a good interoperable ecosystem? Trust minimize. We want to reduce the amount of trust that's present in the system. So for example, it would be great if we don't have to trust centralized actors to pass messages on behalf of us, or for example, it would be great if we don't have to wait 1 week for the confirmation of the messages. So ultimately, I think all of this would boil down to being efficient and cost-effective, and minimizing the friction between minimizing the friction for the user in terms of experience this interoperability. So how can TEs actually help in this? TEs have this very interesting property, which is like it can ensure code integrity and data confidentiality for any code and data that is being executed within the enclave. So this allows us to have a certain property that is really desirable, which is code is law. I mean, back when Ethereum was first founded, that is what we want to achieve with smart contracts, right? We don't have to trust the operators. We don't have to trust the network. The code itself is the law. The protocol, we can encode what we socially determine as acceptable into code, and then we execute as code. And this actually allows us to have like this decentralized access. No longer do we need to trust huge entities to put up huge amount of stakes to prevent malicious actions, right? Because if we have code as law, anyone can participate in this in this protocol. The bar of participation is now lowered. We no longer require large amount of capital to actually participate in this interoperability game. Okay, so really, one of the things that is really interesting is like the rise of intents, and how intents is our quote-unquote silver bullet to solve interoperability problem. Because I mean, if you think about it, users don't really want to say that I want to bridge from A to B. I want to bridge asset from A to B and then do a swap on B, and then take the swap asset and then move it back to A and then perform some other stuff, right? I just want to, I have something that I want to do, and hopefully someone can do it for me. So this intents-based architecture is great, but we need to have people that can interpret the intents and solve it for us. And to be honest, this XKCD comic kind of like says it all. That's like everyone have their own way of designing their own intent systems, and it's kind of hard to get everyone to agree on a certain standard. And this is fundamentally what the interoperability problem is. So how can we solve that? Maybe we can make use of AI agents or agents. I kind of like stole this from Tomasz from Netherminds. So what we can do is we can actually use AI agents as a sort of UX abstraction for interoperability between all the different chains. If you think about that, what we are doing is making use of AI agents or models as a way for users to delegate the actions that is needed to perform the actual operations, interoperability operations. So users just need to specify a particular intent. We can have a model that is fine-tuned or trained specifically to certain operations that we are interested in doing. That can be 20, 30, 14 different standards of communication. We can all put it into this huge LLM model. The model can understand how to format the intent, how to so the model can understand what the user wants and kind of like map it into the specific intents. So I'm kind of like running out of time. What we have here really is a whole bunch of open source tools and SDKs for developers who are interested to build this future of interoperability between the chains. We have on-chain attestation verifiers, SDKs, like databases and stuff like that. So we are really very excited and happy to see people using it, so please use it. And I kind of like want to end off this presentation with these questions, like AI plus TEE plus intents. Is this really the crutch, the solution, or neither? In my personal opinion, I really do think that having TEEs to provide the kind of like trusted execution base coupled with intents, and having an AI or kind of like an LLM agent as the abstraction or the user interface would be the future for interoperability. So thank you. That's the end of my presentation.